Hi and welcome to today's class. So today is the 30th of April and this is class number 56. So we're going to continue on with our probability chapter and we're going to look at another way where we can work with multiple events. So on Monday we looked at sample spaces. So we're going to see something today called a probability tree diagram. So some people like this more visual approach. So we're just going to do some examples and then you're going to try one yourself for homework. Before we move on, I'm going to correct the homework that I assigned you on Tuesday. Apologies, on Tuesday. So a game is played using two spinners, as shown below. We have a spinner that has a 2, 4, 6, and a spinner that is A, B, C, D, E, and F. So they asked us to list all the possible outcomes in the table. So they had drawn this lovely table. I know you guys probably had to actually go and draw it yourselves, but I'm just going to fill mine in. So I have 2 and B, or I could get a 4 and a B, or I could get a 6 and a B. Hopefully we were all okay filling this in. We got a 2 and a C, a 4 and a C, or a 6 and a C, or a 2 and a D, or a 4 and a D, or a 2 and an E, 4 and an E, 6 and an E, 2 and an F. Oh, my 2's gone a bit funny. 4 and an F, so is that an E? And a 6 and an F. So mine's quite squished. Hopefully yours weren't as squished. So how many outcomes contain the letter E? So here are all the ones that contain an E. So there are 3 outcomes that contain an E. So then what's the probability of getting an E? So there's 3 E's out of how many outcomes? So remember, we have a table here that is 3 and it goes across by 6. So 3 by 6 is 18. You could count them, or you could use that fundamental principle of counting. So actually we get 3 over 18. Now, 3 over 18 is not as simple as it can be, so this would simplify to 1 over 6, because 3 divides into the top and 3 divides into the bottom. So good practice to revise what we've already done about fractions. So then it says, I'm going to get rid of, try not to rub out all my work. Great. Then it says, what is the probability of an outcome containing a 6? So a 6. So we have all of these guys here. So there are 1, 2, 3, 4, 5, and 6. Again, out of 18, but this can be simplified as in 1 in 3. Then it says, what is the probability that the outcome contains an E or a 6th? Now, this is kind of interesting because there are 3 outcomes that have an E and there are 6 outcomes that have a 6, but yet there are only 8 outcomes that have both an E or that have either an E or a 6. And the reason we're kind of short one as such is because one of them, oh again, that's bad color, this one has a 6 and an E, so we can't double count it. So my answer is going to be 8 over 18, which simplifies as 4 over 9. So hopefully that was okay. If you have any questions, please let me know. So let's look at an example. Sam has a bag, and in the bag he puts 6 blue balls and 4 red ones. So here they are in this shopping bag. What is the probability of getting a red ball? Okay, so hopefully we're all okay at this point. There are 4 reds out of a total of 10. So we get 4 in 10. But we also know that actually it could be simplified. Oh, and they didn't simplify it, but it would have simplified to 2 over 5. So then he picks one ball and records it and puts it back. He then picks a second ball, records the colour. What are all the different outcomes? So now this is interesting because we now have 2 events. We don't just have one single event. We don't just have one pick. He takes 2 picks. So we can draw something like this. So he could pick a blue and a blue. Or maybe he'd pick a blue and then he picked a red. Or maybe he picked a red and then a blue. Or maybe he'd picked a red and then another red. So there were 4 different outcomes that he could have had. Now, some of you are saying, but I could have told you that that was 4 using the fundamental principle of counting. 2 outcomes for the first pick and 2 outcomes for the second pick. Fundamental principle of counting says 2 multiplied by 2 equals 4. So using a sample space, we could do something like this. But are each of these 4 outcomes equally likely given that there's a different number of red and blue balls in the bag? And the answer is no. So you might think you have the same chance of getting all 4, but you're not, because if you go back to the question, we had more. So remember, we had more of one ball than we had of the other. So in this case, because they're not all equally likely, we're going to use something called a probability tree diagram. So what does this look like? Well, we're going to draw branches. That's why it's called a tree diagram. It has branches. So we start at our starting point, and it could go either way. We could pick a blue ball, or we could pick a red ball. So there are 2 outcomes. Then we have a second pick. So maybe we had a blue ball, and then we would have got either a blue ball or a red ball. Or if we had picked a red ball first, we get a blue ball or a red ball. And now we have all the different outcomes. So same outcomes, but we're going to have a much easier way to figure out the probability. So example, a coin is flipped 3 times. Use a tree diagram to show all the possible outcomes and probabilities. So we have, it could be heads or it could be tails. If we get heads, the second flip, we could get heads or we could get tails. If we'd had tails, it could be heads or it could be tails. Now it's going to get very big very quickly. So we have heads could get another heads or tails. That tails could give me heads or tails. This head give me head or tails. And this gives me heads or tails. And mine is not very pretty at all. But yours could be much prettier. Now let's make a look at our outcomes. That could be heads, heads, and heads. Or we could have heads, heads, and tails. Here we have heads, tails, and heads. Heads, tails, and tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And finally, tails, tails, tails. And there are there are 8. Miscounting. 8 outcomes. Now we could have used our fundamental principle of counting. 2 outcomes by 2 outcomes by 2 outcomes. 2 by 2 is 4, by 2 is 8. But they wanted us to list all the outcomes. Now with heads and tails, they'll all have the same chance. So each outcome is going to have a 1 in 8 chance of occurring. Now, for tomorrow, you're going to try one of these yourselves. There is a bag with 2 red stars and 4 green stars. Find the probability of picking a red star and the probability of picking a green star. That's what P bracket red means, the probability of picking a red, the probability of picking a green. And then I want you to draw a tree diagram to show 2 picks of the bag. So very similar to the first example that we did with regards Sam and the bag. So do your own tree diagram and submit that, and tomorrow we're going to do our final lesson on probability, and then we'll be able to bring all of this together. Like always, if you have any questions, please let me know.